With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? That there is a uniformly charged hemisphere of radius b carrying a charge density rho, and it is having a spherical cavity of radius a where there is a relation between a and b. A is equals to b by 2, which is cut from its center. Now, if the potential at the center of the cavity is n rho b square divided by 16 epsilon, we need to find what would be the value of n. Okay, we need to find what would be n. Okay, now in this case, okay, so since we can say that charge would be uniformly distributed, okay, charge is uniformly distributed. So first of all, we just draw our this hemispherical cavity, hemisphere. Let's say this is the upper portion of the hemisphere and this is this round portion of the hemisphere. Okay, now in this case, the charge density is given as to be rho. So we can say that since this charge would be distributed, okay, charge would be distributed across all the shells. So we can say that a small potential dV would be equals to K times dq divided by r. Okay, so this would be the case where dq would be the small charge at a distance of r from the center. So we just draw our this line element. Let's say this would be what we are saying. So this is the center. We have just taken a hemispherical cavity inside this. Inside our this is spherical cavity. Okay, like this we have taken a this hemispherical cavity. Okay, now we are just calculating the potential due to this part. Okay, then due to the rest of the part we can integrate it. Now due to the cavity we can just take the limit from a to b. We can do it like this. Now what would be the charge dq? We know that dq could be written as, our charge dq would be written as volume charge density has been given. So it would be volume multiplied, this density multiplied by volume. Okay, because this is charge density, that means charge divided by volume. So we need to find the volume. So what is the volume of this cavity which we have, or we can say that elemental hemisphere which we have taken. So basically this is an hemisphere. So the surface area would be equals to what? It would be 2 pi r square. Okay, now if you multiply by the thickness, okay, this thickness would be our dr. If you multiply by dr, so this would give us the volume. Okay, where r is the radius, this is our r. Okay, now we can just put it into our expression. So our dv would be then would be written as k. K value is 1 by 4 pi epsilon. We just substitute the value. Okay, then it would be dq. Dq value would be rho 2 pi r square dr divided by r. This would be the case. Now to get the total potential at the center, so we can just integrate this. Okay, now if we integrate this part, so what are the terms which are common? So we should take it outside. And what would be the limit? Limit of r, because this is a cavity, so the charges would be starting right away after a and it would end at b. So our this limit would be from a to b. Okay, so 1 by 4 pi epsilon we can take it to be common. Then 2 pi rho we can also take it to be common. Then we can put the limit from a to b and it would be r dr, because one power would be get cancelled. So what is the integration of r dr? We just write here. So it would be equals to r square divided by 2, and then we can put the limit from a to b. So we will be just using this integration. We just write this is our integration. Okay, with the limit from a to b, we will be using this result. So our potential would then look like, so it would be pi and pi would be cancelled. So it would be 2 pi and then it would be rho 2 pi rho, and we are just writing pi itself. So 4 pi epsilon. Then it would be r square divided by 2. So we just take the value, put the limit. So it would be b square minus a square divided by 2. Okay, now we see that 2 and this 2 pi would be cancelled. So v would be equals to rho divided by 4 epsilon. Now what is the value of b? B would be equals to twice of a, which is given. So if you put the value, so it would be 4a square minus a square, that means 3a square. Okay, so this would be the potential. Now what we need to do? We need to compare it. Now in the comparison it is given as to be b, so we just change a to b. So because in the comparison it is not given in terms of a, but it is given in terms of b. So it would be rho divided by 4 epsilon into 3, then a value would be equals to b divided by 2. So it would be b square divided by 4, or we can say that it would be 3 rho b square divided by 16 epsilon. Now if we compare it with n rho b square divided by 16 epsilon naught, so we clearly get the value of n as to be equals to 3. This would be our answer. So which is the correct option? Correct option is our A option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.